Greetings, everyone, and welcome back to our last chapter. It's not our last chapter in the book, but calendar is allowing me to go just so far, right? So we're gonna head into chapter 12, and we're gonna be taking a look at the I titled this there, the geography of natural resources. And there's a couple of things in my lifetime that I did not think I'd ever see. One of them was the fall of the Soviet Union. That happened when I was 30, 31. Grew up with during the Cold War. I never ever thought I would see our economy at I don't know how many million are out of work right now and still counting. We got to do something about that fast. The other thing I never ever thought I would see would be the day the United States would be energy independent. So we're going to talk about that today, and it's a new wrinkle to the course. I had to um, make some additions from where we were at uh, last time the additions came out for this textbook. And I'm going to be talking about fracking. I'm excited to be talking about that. But and I'm also excited that this is the last time I will have to do this. Boy, do I miss the days of just coming in and with my lecture notes and you know not. I thought I would enjoy this technology, messing around with the technology here, being on camera, and camera doesn't bother me. Set up, recorded. I'm not going to miss it, but I digress. If you have your lecture model, turn to the objectives, and we'll talk about the heads up terms. I guess I have the heads up terms first. I'm going to do the objectives. First, and we're going to recognize major sources of renewable and non-renewable chapter. Perhaps formulate some kind of an opinion on domestic energy policy, right? And investigate forest and wetlands usage as well. Some of the major heads up terms that I'm going to tip you off to right off the bat here would be, of course, non-renewable resources, and they are basically resources that we can run out of, or they just generate too slowly. Renewable resources are the inverse of that. That nature replenishes. These are the resources that nature replenishes. I'm going to talk about nuclear fission and nuclear fusion. Nuclear fission, but nuclear fusion, that is what makes things like the bomb, right? That makes things like it creates the bomb. Oil shale. Oil shale comes from a sedimentary rock that contains shale oil. You hear about that sometimes in the news. Tar sands, we'll get to that a little bit too. Tar sand, organic terms, what we know as asphalt, right? And what else do I have? That the estuarine zone. Estuarine zone, that is the border, if you will, or where fresh and salt water meet. Okay, estuarine zone. And proved reserves. Proved reserves, these are where we know we have oil reserves, right? ANWR up in Alaska, I guess, has been there's known reserves there, but it was always, how much was there, how much was actually there. And fracking, adding that to my roster this year, kind of a hydraulic fracturing, drilling, and we'll investigate that. So the details and certainly the pros and some of the cons of that. So let's dive into this. Natural resources are a matter of perception as well as occurrence, and their uneven locational and demand patterns and their roles in economic development and world trade make research appropriate geographic study. Non-renewable resources are subject to depletion, although some may be recycled at a cost. Renewable resources, these are resources that are those for which replacement cycle is short and amenable to practices of sustained use. Let's take a look at our first set of notes here right off the bat. Renewable resources. Talk about renewable. This is material that replaced by natural processes, and it's used over time and gets replenished. Non-renewable resources, these are finite, a finite amount to it, or it just generates too slowly to be counted on. Fossil fuels, nuclear fuels, and basically you have a lack of alternatives. Figure 12.3 on page 339. For those of you where some of the proved resources are, and that's my last point here. Proved resources, these are quantities that can be extracted from known reserves, right? We know where they are. Energy supply. Energy supply may be non-renewable or renewable. Among the non-renewable are fossil fuels, coal, and coal has decreased in value, and oil and natural gas have increased in relative importance in world use. Oils, there's a function and enters importantly into international trade. The ultimate depletion of oil reserves has rekindled interest in nearly inexhaustible coal reserves. Let's take a look at oil first here, though. Oil's adaptable. All right, you have your white space there. Oil's adaptable for power vehicles. We love that. Major output for refineries. It's efficient to transport. Pipeline, oil tankers. At a low cost. At a low cost. Figures 12.7 and 12.8. It's really dark today. It's a Friday here in Holsapple. By the time you guys see this, of course, it'll be Monday. Hopefully it's lighter. Right. Figures 12.7 and 12.8. Great inset maps here. Major shipments as of 2014. Shows you where they're coming from, where it's going to. Figure 12.8 on the same page, 340. Regional shares of proved oil reserves, right, in billions of barrels as of December 31st, 2014. So something you might want to take a look at. Pages 340 through 343. We're going to get to coal here in a minute. Some more inset maps. Here's the thing. The U.S. Had imported about 60% of its oil that it consumed. Some of the major producers, and think about these. Some of these countries. Some of the major. I'm going to get some light on here. It's getting darker. There we go. Some glare out of here. Some of these countries, you have Russia, right? Russia, not exactly an ally of the United States, right? Saudi Arabia, It depends. The North African countries, right? Not so much. Venezuela, not really. And there's Alberta up in Canada, right? Pretty much reliable allies, the Canadians. More of it's found in the Gulf of Mexico as well. More of it's found in the Gulf of Mexico in our international boundaries. Fracking. Let me talk about fracking in regard to all this. Fracking, or hydraulic fracturing. It's done vertically and laterally drilled, right? Vertically and laterally drilled. It's chemically treated, water and sand, and it's applied with great pressure to crack tight rock formations. The sand acts as a wedge to allow the oil to get to the well. So as a result, the economic reserves of petroleum has resurrected ghost towns into boom towns up in the northern Midwest. And fracking is America's modern miracle of newfound energy reserves. In reality, as I said earlier at the top of this, it's almost inconceivable just a decade ago. It has produced an oil and gas boom in the U.S., and it's helped reboot the economy while causing oil and gas prices to plummet. For the consumers. And I guess the big picture is that, because of fracking, I met just some of those countries, all those countries I just mentioned, we're pretty much energy dependent right now. And like I said earlier, it's something that would have been inconceivable to think about 10 years ago. The current administration has really opened that up. Science of fracking, though, is far from settled, right? I called this information. I have to get back to where I have my citations for this, but there are some pros and cons, right, to fracking. I think what I'll do is I'll send you maybe I'll send you an FYI on that. Okay, I think some of you will find that interesting. But variations in coal, we'll start moving to coal, variations in coal's physical and chemical properties, the conditions of, as I set this up here, the conditions of mining and proximity to the market are spatial variables affecting its use, as are the alleged environmental problems its use may occasion. Natural gas in the United States accounts for some 25% of energy production. Like oil, natural gas is also used as an industrial raw material. Let's take a look at coal here. Let's break that down. Coal, it's non-renewable. It's non-renewable, although reserves are said to be in the centuries. 250 billion tons of it are here in the United States. And you could turn to figure 2.9 on page, let's see, 342. Good illustration there where the known coal reserves are. Figure 12.9, I think that is, yep, 12.9. But coal energy supply has increased in the United States over the past 50 years, right? Electric power, it's good for electric power generation, making coke for steel production, heating homes, right? The coke is basically, we get back to that, it's a solid residue of um, impure carbon used as fuel and making steel. So the value of it, though, the value of the coke, is the rank and grade, the accessibility of it. Much of the mining, however, is dangerous and expensive. Some of you know folks that are in that industry. Very, very prevalent up here in the Alleghenies, right, western Pennsylvania, where we are. Mining's dangerous. It's expensive. You have your shaft mining. Surface destruction comes with this. Lake contamination. Costly to transport. Usually not a long export route. Has to be near coal hubs like Pittsburgh, right? We're not too far from that. And this is what makes fracking so important today, right? It's a lot cleaner than, there's no question about that. There's some issues with it, but there's no question that it's cleaner than coal. Natural gas. Natural gas, looked at as the perfect energy source. Methane, least impact on the environment. 25% of global energy production. It's used for industrial and residential heating. Flows cheaply by pipeline. Methane air is explosive, but it's protected by pipeline. And that's under investigation too, as with fracking. There's been a lot of technological improvements to make, the pro-fracking camp is kind of playing this down, the potential adverse effects of methane, right? The technological developments to make those the potentiality for problems there slimmer, I guess, what I'm trying to say. Russia, there it is again. Russia and the Middle East contain most of the proved reserves of natural gas, about 70% of it, right? Again, this is why fracking is so important. We did have potential reserves in Alaska as well. And then I'm trying to think here, page 348. 348. I was going to say something else here, but I think I'll hold off on that. Page 3. Page 345, figures 1211 and 1212. Some inset maps on proved reserves. Oil shale and tar sands. Oil shale and tar sands. Oil shale, a fine grain rock containing kerogen, and that's an organic material. It's an organic material. It's a waxy-like substance, tar-like substance, and it gets crushed and heated to about 900 degrees. The kerogen gets decomposed, becoming liquid oil shale. Figure 1213 on page 349. Sorry, again, 346. 346 to update my textbook here. Oil shale deposits. There's enough oil shale in the U.S. provided oil shales to supply Americans for oil for another century. Tar sands, bitumen saturated, kind of a mixture of organic liquids that are, sticky, entirely soluble. It's a residue in distillation and found in coal tar, which occurs in things like natural asphalt. Considered to be larger than your typical oil reserves. Several tons, mostly in Alberta. Mostly in Alberta, about 10% of Canada's oil demand is there. And you can see on figure 1214 some, well, an inset map there of Alberta and how much of those fields take up a portion of that province. Venezuela, Russia, and Utah have a wealth of resources. But here's the thing with that, carrying both is expensive, and there are environmental questions. Okay, again, importance of fracking. Nuclear power. Nuclear power has two major ways of getting generated. There's nuclear fission and nuclear fusion. Fission splits atomic nucleus of uranium-235, which converts to heat, which creates steam, hence drives turbines and creates electricity. Nuclear fusion, on the other hand, this is where atoms get split in the form of hydrogen. So, and fusion is what makes the sun burn, and it's used to make the bomb, as I said earlier. But it's not controlled. Figure 1216. I'm almost afraid to say the page numbers. Figure 1216. You see, interesting, interesting visual there, because it tells you where the operating nuclear power plants in the United States are as of 2016. And you'll notice that they're probably not as many as you would think there would be. And the reason why, there really hasn't been any new plants generated since 1979. There was some 1979 meltdowns, and they've been costly. So there haven't been any. Last decade, there was a plant down in Georgia that put in an application to be built. I actually think that went through. Probably check that out. But so I'm going to move now to the second half of the lecture and this lesson into renewable energy resources. And renewable energy resources include biomass, hydropower, solar, tidal, wind, and geothermal power. Wood and manure are important sources of energy in developing countries. Hydropower in both developed and developing countries can be found. Supplies roughly about 25% of the world's electricity. So your non-fuel mineral resources are non-renewable, but they're sometimes recyclable. And their extensive use has depleted supplies in many countries, increased international mineral trade and dependencies, and necessitated use of higher cost, lower quality reserves. So as in the case of energy supplies, the future of mineral utilization demands wiser management, greater resources, and perhaps lower levels of economic expectation. Let's break some of these down here. Biomass fuel. Biomass fuel. Biomass fuel, we're talking about plants, animals, wood, and it gets burned into heat source or converted into liquids. So wood is a key source in the developing world. For example, they use it for cooking, heating, and lighting. Waste, animal and human refuse or waste. and in developing countries gets fermented to methane gas. Biomass supplies an insignificant amount of energy, though, in the developed world. Hydropower, hydropower, falling water, dams, water wheels. Again, we're talking about all these things here are clean sources of energy. Hydropower, it's generally used in the region where it's produced. It's you know, a main supplier of electricity in many developed and developing countries. Solar energy, solar energy, solar energy, solar energy. This is the origin of all the other sources. Actually, capture of it, the capturing of it can be, as I say here, the salvation of all of the others, right? But the big question there with solar energy is, how do you, how's one collect it? And then after you collect it, how do you store it? Wind. Let's take a look at some of the advantages and disadvantages of wind power. Advantages of wind power, turns turbines without fuel. They can be built quickly. They don't pollute. They don't deplete natural resources. Some of the disadvantages, they're unreliable. They're not continuous. They need a backup system since they're not easily stored. Most are plentiful in remote areas. Therefore, it's expensive to get them to consumers. And it's far from existing power grids. And there's an aesthetic impact too, right? Some of the migrating birdies have been known to run into them, right? Here's the other thing. I'd say maybe the most important thing about the disadvantages, it takes thousands of them. It takes thousands of them to get the same amount of electricity as does one nuclear power plant. About 1/10 of the Earth's surface is used for intensive production of food. Although food production has kept pace with increases in world production, more people than ever before are malnourished, right? And a lot of that has to do with, third world, these tin horn dictatorships and top-down run governments that have really leave no incentives for the folks to produce and create, right? I don't want to digress too much. I don't think the Western democracies put enough pressure on those countries to reform. I think it's easier for developed countries to just continue to supply what's needed in these areas instead of putting pressure on these countries to reform their governments, right? And that'll probably be for government class to riff on that any longer. Why that doesn't happen, right? Why we take the route we do. But methods of increasing the quantity and quality of food supplies include expanding cultivated areas, increasing yields on land already cultivated, and increasing production of fish. So, two types of land resources. You have coastal wetlands and forests, and these play vital ecological roles. Wetlands have been degraded in many parts of the world, and forests are being used faster than they can regenerate in some places, right? That maximum sustainable yield. Let's take a look at wetlands. got some last place here I want you to do some writing. When we talk about wetlands, we're talking about land surfaces that are periodically or permanently covered by or saturated by standing water. Now, in light of that definition, I can tell you this, so probably maybe for some discussion questions, I will furnish some of these examples. There's a lot of mischief that can be done by well, power-hungry state governments. So should there be a limit on what the question is? Should there be a limit on what constitutes a wetland? Grassy marshes, wooded swamps ranging from small prairie potholes to Everglades. That's part of your notes. You should be writing that. Grassy marshes, wooded swamps ranging from small prairie potholes to Everglades. There's a wide range of what constitutes a wetland. Back in 2006, here in my backyard, the township needed to get water and sewage into the community down here. So my house was the first on a row of houses back here, and the caterpillars and whatnot had to come through my backyard, and they completely destroyed that. It took me years to get that right again, but I was always a little nervous about it because, after the winter, I couldn't mow back there until July because there were basically little lakes back there, and it was very expensive to get that repaired, but I was always a little nervous. Fortunately, you really couldn't see it from the roadway, but I was always a little nervous that the wrong person would see it and would kind of cop my property from me, because it could have been maybe deemed a wetland, and there have been people around the country that have lost their property because of the wide range of what's deemed a wetland. Two major categories are inland and coastal. Inland and coastal. Most in the United States, of course, are inland, and that consists of freshwater. Bogs and marshes, swamps, and floodplains. Most of it, I said, is freshwater, right? You have your estuarine zones, right? One of your heads up terms there. And that's where your fresh and salt water meet. And the estuarine zone, they perform several functions. One of the things they do, those zones, they improve water quality by trapping the debris and the pollutants that water brings downstream. And they provide habitat and food for many plants and animals. They act as breeding and nesting grounds for many types of birds. They absorb floodwaters, and they stabilize your shorelines. Wetlands have been looked at as menaces, though, fostering mosquitoes, and therefore dug up for commercial development. They're converted to cropland. They become garbage dumps. They get polluted, and shorelines end up sometimes getting bulldozed as a result of that. The Clean Water Act of 1972 added some federal protection to wetlands, where you can't fill them without permit. Some folks on their own private property have gotten into trouble because they tried to do that, and however you want to look at it, the wrong or the right people, authorities, have found out about it and have stopped folks from developing on their property because of a certain amount of level of after rain waters that still remain on the person's property, and hence been deemed a wetland. Lastly here, forests. 1/3 of the world's land area, right? Ecological purposes, soil and watershed conservation, provision of habitat for wildlife and recreation, global recycling of water, carbon and oxygen. Tropical rainforests extend across parts of Asia, Africa, and Latin America. Some of the benefits of deforestation. Some of the benefits. They relieve high population densities. They give farmers and ranchers a place to develop their livelihood. You need that. You need it. Allows natural resources to get tapped. Assists Brazil in repaying their national debt down the rainforest. Forests in Western Europe and the United States, they were cleared a long time ago. So the so-called exploitation has led to a lot of great wealth, right? A lot of great wealth. And we like our baseball bats, our pianos, right? Led to a lot of great wealth. Disadvantages. Maintains oxygen and carbon balance of the earth. Burning forests allows carbon dioxide back into the atmosphere. Can contribute to so-called warming of the atmosphere. Fire contributes to the depletion, the so-called depletion of the ozone layer, and allegedly causes extinction of thousands of plant and animal species that do not exist outside of Brazil. Tropical rainforest contains important staple crops: rice, corn, squash, banana, pineapple, and sugarcane. Just a side note, if you ever have me over to eat, don't serve banana or pineapple, okay? So they can have those. Now, with commercial forests, commercial forests can be considered a renewable resource if the sustainable yield techniques are practiced. So there are two techniques to sustainable yield. You have your clear cutting. Clear cutting, all trees are removed from a particular area at once. So the site, with clear cutting, the site is left to replenish itself naturally or gets replenished with fast-growing seedlings. The second technique is selective cutting. This is practiced in mixed forests. The older trees are often cut for the sale of younger tree growth, and what has been cut will also regenerate. Clear cutting of the two is seen as the most economic route. So, kind of wrapping this up, our last time together with this. We should be, by the way, the next chapter we're going to get to, and I didn't, is basically gets into some of the things some of you guys did papers on, and that is human impact on the environment. Human impact on the environment. We look at the pros and cons of and what's maybe real and what isn't, right? What's happening, what isn't. But we're not going to get there, right? We're going to end here, the geography of natural resources. So, kind of wrapping, if you have your graphic organizer, putting a wrap on this today. Your renewable resources, right? Renewable resources. These are, let's take a look at, the renewable resources. No, non-renewable. That's what I got started with. All right, I'll get it together here. Non-renewable. These are finite. The amount or the finite amounts, or it generates too slowly to be counted on, right? You have oil, right? Output for refineries, adaptable for power vehicles, easy to transport. Fracking, you can add fracking in there, right? Fracking. Fracking has kind of changed the game on all this, right? Coal, coal reserves, or we have it in the centuries. Electric power, good for electric power generation. Steel production, home heating. Dangerous though, dangerous mining, surface destruction, and it's expensive to transport. Natural gas, right? The perfect energy source. It's methane though. Industrial and residential heating. It's good for that. 25% of your global energy comes from that. Cheap to transport via pipeline. Methane and air mixture could prove a problem, right? Another problem is the proved reserves are in places like Russia and the Middle East. Oil shale and tar sands, right? Oil shale. Enough oil in the U.S. for centuries, at least a century. Tar sand, larger even than your typical oil reserves. Both are expensive to carry. And then nuclear power. You have nuclear fission, produces steam, turbines, electricity, fusion, the energy you get from a burning sun, uh, and bomb making. Your proved reserves we talked about, they're your known reserves, right? There's no guessing about it. Again, fracking has changed the game on that as well too, right? We're doing that right here, right? Here in the Alleghenies. I don't know about you. Here in Holsapple, I've actually had letters about where they're doing it because it's pretty close to the border of my property, right? Renewable energy, natural processes get replenished over time. Biomass fuel, plants, wood, and waste, your animal and human waste. Hydropower, falling water dams, water wheels. Then you have your solar energy. This is the origin of all your energy resources. The questions about it, though, how do you capture it? And when you do, or how do you collect it? And when you do, how do you capture it? How do you keep it all? Collecting it and capturing it. I'll get it together. Wind, you have your advantages, right? No fuel needed for wind production. Built quickly, they don't pollute. Disadvantages, unreliable, not easily stored, expensive to get to the consumers. And then your wetlands, grassy marsh to wooded swamps, a large swath of definitions there. The range from prairie potholes to the Everglades. Categories are inland, coastal, wetlands. The estuarine zone is where your inland wetlands are mostly freshwater, coastal, of course, saltwater, and at some point there, they have to meet, right? And that's your estuarine zone. And at that juncture, you have the functions of your estuarine zone. You have, they become pollutant trapping entities, debris trapping. They provide habitat for your wildlife, and they absorb your floodwaters. And then your forests, right? Ecological benefits. You have your deforestation issues and your tropical rainforests. And then with the forests, a lot of wealth has been made, but there's environmental benefits as well to keeping that, to not cutting. And then you have your, in order to get around that, some of your techniques, right? Two major techniques, clear cutting and selective cutting. The argument there is, especially with clear cutting, they get replanted and second growth trees grow back faster and even stronger. So there you have it. That's a wrap on the course as far as goes from teacher-centered instruction. I will have, as I always do, some practice material for you and keep you abreast of that. Our last quiz, I'll have to get back to you whether we're going to do that or not. If we do a quiz, because the final is a week from, as you guys see are looking at this, it'll be in 1 week. I think what we'll do is we will. I think I'll save the quiz, and I will have you guys. I'll have quiz material from this chapter on the final. You'll probably have a few more things from chapter 12 on the final than the rest of the material. So again, look at your study guide material, what's going to be on the final. Calling information right from quiz material, right from each chapter. So do save your quizzes, and the rest of that stuff be pretty much self-explanatory. So if you have any questions, as always, except for Sundays, I'm available. Get a hold of me, and you guys take care. Hope you guys have a great week, and stay safe out there. And see you next time. Bye bye.